It really is quite something, isn't it? A few years back, blockchains felt so separate, like islands.
Yeah, completely siloed.
And now it feels like every week there's a new bridge, a new connection being built. It's all about linking these different worlds.
Absolutely. And that brings us neatly to today's deep dive. We're looking at something pretty significant. TeleSwap launching the first truly decentralized bridge between Bitcoin and Ton.
Right, and that connection is fascinating. You've got Bitcoin, the original giant, the most valuable blockchain.
Your bedrock.
Exactly, the bedrock. And then you have Ton, which is just exploding in growth, especially with that huge Telegram user base it can tap into. It's very consumer-focused.
It really is. So connecting these two isn't just a technical feat. It potentially unlocks a lot of value.
For sure. And for you listening, understanding this specific bridge, this TeleSwap development, it's really about grasping a key trend in crypto right now. Why do these connections matter? What could it mean for how you maybe use Bitcoin or interact with DeFi down the line?
Yeah, it's about the bigger picture. So let's really get into the weeds on this one.
Okay, let's start with the fundamental question, why? Why build this bridge? Why connect Bitcoin specifically to Ton? What was missing?
Well, the sources we looked at point pretty clearly to let's call it a Bitcoin-shaped hole in the Ton ecosystem.
Okay.
Ton's DeFi scene has been growing incredibly fast. You've got decentralized exchanges, lending protocols popping up, liquidity pools, lots of activity.
Right.
But what it lacked was wrapped Bitcoin, a native way to use BTC within Ton DeFi. And Bitcoin, as you said, it's often seen as that core reserve asset.
Like digital gold, yeah. So having it on Ton, that would bring a certain stability.
Yeah.
Deeper liquidity, maybe?
Precisely. Deeper liquidity, better collateral options for lending protocols. It just broadens the financial tools available on Ton significantly. Think of it as adding a really solid foundation.
Makes sense. And you mentioned the Telegram connection earlier. That must play a huge role here.
Oh, absolutely. Telegram is onboarding users to Ton at an incredible rate through all those mini games, integrated apps, the wallet. It's seamless for millions.
So you've got this wave of new users coming into the Ton ecosystem.
Mm-hmm.
And it's natural they'd want to interact with Bitcoin, right? Buy it, hold it, maybe use it in those Ton-based apps without having to jump through hoops on external exchanges.
Exactly. The demand is almost certainly anticipated. And think about convenience. Ton already has, over $1 billion in USDT locked.
Yeah, the stablecoin liquidity is huge.
So imagine being able to swap that USDT directly for Bitcoin, right there within the Ton network, within your Telegram interface, potentially. No centralized exchange needed.
That's a really compelling user experience, especially compared to the current complexity sometimes involved.
Right. It fits perfectly with Ton's vision of being this consumer-first, easy-to-use blockchain. So bringing Bitcoin in natively, trustlessly, it strengthens that whole DeFi ecosystem and supports that core vision.
Okay, so the why is pretty compelling. Stronger DeFi, better user experience, tapping into Bitcoin's value. But the sources also stress that actually building this wasn't easy. Not like just deploying another contract on an EVM chain like Ethereum.
No, not at all. Building on Ton presented some unique engineering challenges. It's fundamentally different architecturally.
Different how? What were the main hurdles they had to overcome?
A really big one is Ton's asynchronous network architecture. That's a mouthful, but it's key.
Okay. Asynchronous versus synchronous.
Yeah.
Like on Ethereum.
Exactly. On EVM chains like Ethereum, you have what are called atomic contract calls. One contract can call another, get a result back, all within a single indivisible transaction. If any part fails, the whole thing typically rolls back.
All or nothing.
Right. Ton doesn't work like that. Interactions between smart contracts happen through separate messages. Contract A sends a message to Contract B. Contract B processes it, maybe in a later block, and sends a response message back to A.
Wait, so it's more like sending letters back and forth rather than having a direct phone call.
That's a pretty good analogy, yeah. Each message is processed independently. You have to explicitly design your system to handle a request, wait for the response, and deal with the fact that these steps might happen across different blocks.
That sounds complicated, especially for something sensitive like moving assets.
It adds significant complexity. Think about just reading a price feed from an on-chain exchange. On EVM, maybe one call. On Ton, it's send a request message, wait for the response message, process the response. You have to build reliable, failure-tolerant processes around that message passing. User safety depends on it.
Okay, and you mentioned rollbacks. The sources said Ton handles failures differently too.
That's the other side of the coin. Because interactions aren't atomic, Ton doesn't automatically roll back a whole sequence if one part fails midway. So the developers have to build that failure handling into their smart contracts. They need custom logic to detect errors, manage any state changes that already happen, and figure out how to recover or refund users if something goes wrong.
Wow, okay. So you can't just rely on the underlying chain to sort it out if there's a hiccup. You have to code the safety net yourself.
Pretty much. It's an extra layer of complexity and responsibility compared to EVM development.
And then there's the programming language itself, Func, right? The sources described it as pretty different from Solidity.
Very different. Func is described as low-level, minimalistic. Solidity has a higher level of abstraction, meaning it hides some of the underlying blockchain complexities from the developer.
So with Func, you're working closer to the metal, so to speak.
Yeah.
Dealing with more raw details.
That's a great way to put it. With Func, developers need to manually manage things like how data gets loaded from storage, how much gas to allocate for operations, even constructing the exact format of those messages we talked about.
Whoa.
And there isn't the same mature ecosystem of libraries like OpenZeppelin that EVM developers rely on for standard secure components like token standards or access control.
So more building from scratch, more potential points of error.
Definitely more building from scratch, which means more code to audit and test rigorously. The sources also mention specific difficulties like handling large data structures or calculating hashes efficiently due to Ton's memory model and the tooling still being less developed than for EVM.
Debugging must be harder then, too.
It can be, yes.
Okay.
And that manual gas management is critical. If you mess up the gas calculations in Func, your transaction might just fail unexpectedly, or worse, you could introduce security vulnerabilities.
Yikes.
So, yeah, writing secure, reliable contracts in Func requires incredible precision and a really deep understanding of how Ton works under the hood. It's not for the faint of heart.
Okay, so clearly building this bridge was a major technical feat, way beyond a standard deployment.
Yeah.
So how did TeleSwap pull it off? How did they build something trustless and secure given all those challenges?
They focused on two core components, according to the sources. First, implementing a Bitcoin Lite client directly on Ton. Second, using economic security through a slashing mechanism.
All right, let's break those down. A Bitcoin Lite client running inside Ton smart contracts. How does that even work?
It's pretty ingenious. Instead of relying on some external servers or a group of off-chain nodes to tell the Ton chain what's happening on the Bitcoin network.
Which you have to trust.
Exactly, which introduces trust assumptions. TeleSwap's approach is different. Their smart contracts on Ton actually contain the logic to verify Bitcoin block headers themselves.
On-chain verification.
Yes,
Yeah.
fully on-chain, inside the Ton smart contracts. This is what makes it trustless at the protocol level. The Ton contract doesn't need to trust anyone about the state of Bitcoin. It can check for itself.
Okay, how does that check work? What are the contracts actually doing?
Well, participants in the protocol submit Bitcoin block headers to the TeleSwap smart contract on Ton. The contract then runs checks based on Bitcoin's own consensus rules. It verifies the proof of work, checks the difficulty targets, makes sure the block hashes link together correctly to form the valid Bitcoin chain.
So it's computationally checking the Bitcoin blockchain's integrity right there on Ton.
Precisely. And the sources emphasize that the contract doesn't blindly trust the submitted data. Every critical piece, the difficulty, the hashes, the header chain itself is rigorously validated inside the smart contract code.
Got it. So it's not just taking the node's word for it.
Not at all. And because the Ton smart contract has this independently verified chain of Bitcoin headers, it can then do something really powerful. It can cryptographically prove that a specific Bitcoin transaction actually happened and is included in a valid block.
So it can confirm the Bitcoin deposit on the Bitcoin side.
Directly on Ton using the verified headers before it allows the corresponding wrapped Bitcoin, let's call it TBTC or something similar, to be minted on the Ton side. No external oracle or confirmation needed.
That sounds incredibly robust. The trust is purely in the math and the code of the two blockchains.
That's the goal, and that brings us to the second pillar, economic security, the slashing mechanism.
Right, so the Lite client ensures the data is correct, but how do you ensure the participants behave correctly? That's where slashing comes in.
Exactly. It's about incentives. Nodes that operate the bridge, maybe relaying those headers or facilitating the process, have to stake collateral, put some skin in the game.
Okay, like a security deposit.
Sort of, yeah. They lock up assets. Now, if a node tries to cheat, say, they try to trigger the minting of TBTC on Ton without a valid corresponding Bitcoin deposit being verified by the Lite client.
What happens?
The protocol is designed to detect this deviation. And if cheating is detected, the smart contracts automatically slash that node's collateral. Their staked assets are confiscated by the protocol.
Ouch. So there's a direct automated financial penalty for misbehavior.
A significant one. And crucially, the sources mention user protection. If a user somehow loses funds due to a malicious node's actions, the slash collateral from that node can potentially be used to compensate the affected users.
Okay, so it makes being dishonest incredibly expensive and risky for the operators, while also providing a backstop for users.
Precisely. It aligns incentives strongly towards honest participation.
So putting it all together, you've got the on-chain like client, cryptographically verifying Bitcoin state directly on TON, removing trust in intermediaries.
Okay.
And you've got the slashing mechanism making it economically irrational for participants to try and cheat the system.
That's the combination. That's how TeleSwap delivers what the sources call the first truly decentralized Bitcoin bridge to ton. It avoids centralized custodians. It avoids trusted validator sets, which have often been points of failure in other bridge designs.
Right. And the big takeaway here, for you listening, isn't just the technical cleverness, though it is clever. It's that this potentially unlocks so much for Ton's DeFi ecosystem.
Absolutely. Bringing Bitcoin's immense liquidity and established trust directly and natively onto Ton in a decentralized way. It fills that gap we talked about earlier.
It really lays the foundation for maybe a whole new phase of DeFi on Ton, one powered significantly by Bitcoin.
Yeah, the sources definitely frame it that way. It feels like a critical piece falling into place and likely just the start of seeing what becomes possible with this new liquidity.
So, quite a journey. We've seen TeleSwap tackle some really deep, fundamental challenges with Ton's architecture to build this decentralized bridge.
Yeah.
It's a significant step, not just for Bitcoin and Ton, but maybe for that whole idea of a more connected, interoperable Web3.
Indeed. It's a testament to the engineering effort involved. And, it really makes you think, doesn't it?
About
Well, as we see more of these sophisticated, trust-minimized ways to move assets between fundamentally different blockchains emerge, what does that mean long-term?
right.
Could this kind of seamless, decentralized cross-chain capability be the thing that finally breaks down the remaining walls between ecosystems? Could it make digital assets truly fluid and accessible, paving the way for, genuine mainstream adoption?
That's the big question, isn't it? A truly interconnected digital economy built on these kinds of bridges? Definitely something to mull over.